Good day, students. Welcome to math.sort.com. In this clip, we're going to be going over how to factor quadratic expressions. All right, the instructions for the examples that we're going to be factoring are as follows. We are to factor each expression completely. Okay? All right, let's take a look at question number 1. Let's say we have the quadratic expression x squared plus 16x plus 60. And the task here is to factor this expression completely. Now, when you have a quadratic to be factored, the first thing you want to ask yourself is what type of quadratic is this? This quadratic is a trinomial, a quadratic trinomial. So if you have a scenario like this, you want to think about using a method called the X game, okay? So the X game is as follows. We're going to create our nice little X. We're going to put AC on the top spot right here, and beagles on the bottom. Now, since we have this quadratic expression written in descending order of degrees, we can easily determine that A is equal to 1, the coefficient of x squared, B is equal to 16, and C is equal to 60. So AC is 1 times 60, that gives us 60 on the top, and B is 16, that goes right on the bottom. Now, if we take a look at this quadratic expression, one thing I didn't indicate earlier was that if you take a look at A, B, and C, you can clearly see that there isn't a common factor that we can extract. Okay, so we can go right into the factorization process. Now, to play the game, we're going to ask ourselves the question, what two numbers multiply to give you 60 and add to give you 16? So some of you might easily determine what combination that is, but sometimes you might have a problem where it is not obvious the combinations of factors that can generate the desired sum or difference. In that case, what you do is write down the target product. In this case, it is 60, and we'll just list all the pair of numbers that multiply to yield 60. Okay, so let's start from the very first one. 1 times 60 yields 60. Now, a combination of 1 and 60 yields 61 or 59. The target is 16, so this pair does not work. Moving on, does 2 go into 60? Absolutely. 2 goes into 60 30 times. This combination yields 32 or 28 when you add or subtract. That doesn't work. Let's move on to 3. 3 goes into 60 20 times. Now this combination yields 23 or 17. That's not the desired combination that we want. So we'll keep on going. Okay, we'll keep on going until we hit the desired pair that gives us 16. So does 4 go into 60? It certainly does. 4 goes into 60 15 times. If you combine this, the sum is 19, and the difference is 11, so that doesn't work either. So move on to the next combination, which is 5. Does 5 go into 60? Yes, it does. 5 goes into 60 12 times. 5, yeah, 12. 50 plus 10 is 60, yes. So 5 goes into 60 12 times. This combination yields 17 or 7. When you subtract, that's not what we want. We want 16. Next pair, 6 goes into 60 10 times, right? So if you add this, you get 16. Voila, that's exactly what we want. So let's group them. This is the desired pair. There's no need to continue. So we have 6 and 10. Now we'll ask ourselves, do these numbers work? Anytime you populate your X game with numbers, you must always test them to ensure that they work, both the number and the sign. Okay? So 6 times 10 is 60. Good. 6 plus 10 is 16. Excellent. Now, in this case, we have a situation where A is equal to 1. Okay? Anytime you have A equal to 1, you do not have to factor by grouping. You can jump directly to the factored state. So we're going to factor this as x plus 6, since we have a positive 6 here, times x plus 10, since we have a positive 10 there. And that, ladies and gentlemen, is the factored form of the quadratic trinomial x squared plus 16x plus 60. Okay, let's take a look at question number 2. Let's say we have x squared minus 25. Now, remember, you want to examine whatever expression you're given and ask yourself, what type of expression am I dealing with here? If you take a look at this expression, you notice that x squared is a square, 25 is a square, and you have a minus in between them. There's a special terminology for expressions of this nature. They are called difference of squares. All right? And there's a unique formula that can be used to really facilitate the factorization of difference of squares. If you have that formula mastered, you can easily factor expressions like this rather quickly. Okay? So the formula is as follows. If you have a square, let's write this down. Formula. If you have a square minus b square, remember you need to have two squares and a minus. This simply becomes the square root of the first plus or minus square root of the second. You're going to write it as the product, the product of the sum and difference of the square root of these two terms. Okay, so we have a plus b times a minus b. So this is the factored state of difference of squares. So now we're going to apply this formula in the factorization of this difference of squares. Okay, so to do that, we are going to root the first and the last term. Remember, they're both squares, so taking their square roots should not be a problem. And then we're going to write the sum and the difference of these two and express them as a product of each other. Okay, so the square root of x squared is x, plus the square root of 25 is 5, and then the square root of x squared is x, minus the square root of 25, which is 5. Okay, so that is the factored state of the original polynomial expression, which was a difference of squares, x squared minus 25. Okay, let's take a look at question number 3. Now, what if we were to factor the expression x squared minus 5x? Okay, let's take a look at what we have. Is this a difference of squares? If you notice, we have a minus here, which is a difference. That's good. X squared is a square, but take a look at this second term here, 5x. Neither of them are squares, okay? So we want to combine both of them together and ask ourselves, do they form a square? And the answer is no. 5x is not a square, hence this is not the difference of squares. So since this second term is not a square, we cannot apply the difference of squares formula here, okay? So we're just going to ask ourselves, can we factor out a greatest common factor? And the answer is yes, we can factor out x. If we write it in the composed states, we can write this as x times x minus 5 times x. And you can clearly see that we have a common factor here of x, which we can simply factor out x, and we're left with x minus 5 to give us the completely factored state of the original expression, x squared minus 5x. Okay, so what you want to learn from this problem is that you really want to closely examine the problem you're given to make sure that it's consistent with a particular formula before you apply it. Okay, this is not a difference of squares, so you cannot use the difference of squares formula here. All right, let's take a look at question number 4. Question 4, let's say we have the expression x squared plus 5x plus 35. Now, what we have here is a quadratic trinomial. All right, whenever you see a quadratic trinomial, you want to use the x game. So before we do that, let's ask ourselves, is there a greatest common factor that I can extract from these three terms? And the answer is no. There's no greatest common factor that can be factored out. So let's proceed to the next part, which is to use the x game. We are going to put AC on the top and B on the bottom. AC is what? Let's list what A, B, and C are, okay? So A is 1, the coefficient of x squared. B is 5, and C is 35. AC is 1 times 35, which gives us 35, and B is 5. Now let's play the game. What two numbers multiply to give you 35 and add to give you 5? That's the question. So we're going to put 35 up here, and let's list all the product of numbers that yield 35. Okay, so 1 times 35 yields 35. What else goes into 35? 5, right? 5 goes into 35 7 times, and I think that's it. So do any of these combinations yield 5 as a sum or difference? 1 and 35 yields 36 or 34. That doesn't work. 5 and 7 yields 12 or 2. That doesn't work either. So what does that mean? This simply means that this polynomial is not factorable. Okay? That's prime. So write not factorable. So it is possible for a polynomial to be prime or to be in a form where it cannot be factored. Okay, so that's a possibility that you want to keep in mind. Okay, now let's take a look at question number 5, the last one in this presentation. Let's say you have 6m to the third plus 18m squared minus 420m. Okay, now what do we have here? This is a cubic trinomial, so we cannot directly apply the x game. Remember, the x game is a method of factoring quadratics. Okay, it can also be extended to higher degree polynomials that have even powers in certain cases. We're going to consider the factorization of problems like that in tutorials to come. Okay, but let's look at this first. We're going to ask ourselves, is there a greatest common factor that I can extract from these three terms, 6, 18, and 420? And the answer is yes. 6 goes into all of them. Okay, and if you look at the variables, m to the third, m squared, and m, you can also factor out m. So the greatest common factor of these three terms, let me put it on the side here, the greatest common factor of 6m to the third, 18m squared, and 420m is 6m. 6m evenly divides each and every term here. Okay? Okay, so what we're going to do now is proceed to factor out 6m from all three terms. So if we factor out 6m, it is as though we're dividing every single term by 6m. So 6m to the third divided by 6m, you have m squared. When you factor out 6m from 18m squared, or you divide 18m squared by 6m, you are left with 3m. And lastly, when you take out 6m from 420m, you're left with 6 times 7 is 42, so we have 70m. You can always check your factorization by distributing back to make sure that you end up with the original expression. Now, what do we have in the parentheses? We have a quadratic trinomial. How do we factor those? We use our x game again, okay? So let's make our nice little x. AC goes on top, B goes on the bottom. All right? So what is A, B, and C? We're focusing our attention on the quantity in the parentheses. Okay? So A is 1, B is 3, and C is negative 70. Okay, now AC, we multiply 1 by negative 70. We get negative 70, and B is 3. Now we'll ask ourselves, what two numbers multiply to give negative 70 and add to give you 3? Let's play the x game again. The desired product is 70. Let's ignore the sign for now, okay? Just focus on the products. Now let's write down the pair of numbers that multiply to give you 70. We have 1 times 70. Combination of these two numbers gives us 71 or 69. That doesn't work. So let's move on. 2 goes into 70, right? 35 times. A combination of 2 and 35 yields 37 or 33. That's not 3, that doesn't work. Let's move on to the next combination. 3 doesn't go into 70. If you add 7 and 0, you don't get a multiple of 3. 4 doesn't go into 70 because 4 doesn't go into 30. How about 5? Since this number ends up with a 0, then it's divisible by 5. Okay? So 5 times what gives you 70? 5 goes into 7 once, and 5 goes into 24 times. Alright, now does this combination, 5 and 14, does it yield the desired sum of 3? 5 plus 14 is 19, the difference is 9, that doesn't work. Okay, so let's move on. 6 doesn't go, 7, absolutely. 7 goes into 70 10 times. And 8 and 9 don't go, we are done, exhausting all the possible products that yield 70. Product of integers. Okay, so does 7 and 10 work? The answer is yes. 7 minus 10 or 10 minus 7 gives us 3. Okay, so let's put that back in here. We have 7 and 10. Now remember, in this problem, A is equal to 1, so we don't have to factor by grouping. We can jump directly to the factored state. Okay, so we bring down the 6m. And the factorization of this quadratic trinomial is m plus 7 times m plus 10. Oh, wait a minute. I made a mistake here. Getting ahead of myself. Okay, so one thing I didn't do was to resolve the sign. Okay, so that's something you want to always do. So when you put the numbers in the x game, you want to ask yourself, does it work? So 7 plus 10 is 17. We need the difference, okay? So let's try this. How about we make 7 negative, okay? If we make 7 negative, 10 minus 7 is positive 3. Negative 7 times 10 is negative 70. Oh, perfect. So that works. Okay, so always check to make sure your x game works before you jump into the factored state, okay? So m minus 7 times m plus 10. All right, now that is the factored state of the cubic trinomial that we have in question number 5. Okay, so that's that. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your study of quadratics, to give us a thumbs up. Your positive feedback is very valuable to us. Any questions and comments about the contents of this presentation or how to factor in general, just include it in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on mathcodeserve.com. Thanks again for watching and have a wonderful day. Goodbye.